Hello everyone, welcome to Maths Easy. Today we are going to discuss about total resistance. Now I'm pretty sure like all of you know how to find the total resistance of a number of resistors connected in series or parallel, right? So most people just know, okay, in series you just add them up, in parallel you take the reciprocals and add them up to get the 1 over R total. But in my experience, when I've checked with many students, they do not know exactly where they come from. So personally, I think it's good to know how to do them, but also it's better if you know exactly why we do this, right? So this is what we're going to explain. Now I'm going to use just two resistors to explain this, but I can use number of resistors and it just works in the same way. Now let's say we have resistor R1 and R2, and the total resistance of this, the combination, is R total. Now in a series circuit, if the current through this is capital I, it's the same current that goes through all of them, and it's the same here. However, in a series circuit, the voltage splits up. So let's say the voltage across the first resistor V1 R1 is V1, the voltage across this one is V2, the total voltage is V total. Now we know the total voltage V total is equal to V1 plus V2. But V is equal to IR. Now what we are going to do, we are going to apply it to every resistor. So V total is IR total. IR total is equal to V1 is IR1. V2 is IR2. Now you can clearly see the total equation can be divided by I. They all get cancelled out. So we are left with the formula. The total resistance of number of resistors connected in series can basically be found by adding the resistance of each individual resistor. So for two resistors, we get this formula R total is equal to R1 plus R2. Now, we can do the same thing or a similar thing really for parallel resistors. Let's do that. Now, here we have a parallel combination of resistors. Now, let's say the current that's coming through this one is capital I. Say call it I total. The current that goes through this branch is I1 and the current that goes through the other branch is I2. The current through this one is I total as before, same current. Now the voltage across the resistors are the same. Now let's say the voltage is V and it's the same here. Now I can clearly see the total current I total is I1 plus I2, conservation of charge or even Kirchhoff's first law. Now I know from V is equal to IR, I is equal to V over R. Now I total is V over R total, I1 is V over R1 plus I2 is V over R2. Now, like before, the V can get cancelled out and I get the formula 1 over R total is equal to 1 over R1 plus 1 over R2. This is the formula that we already know. Now, I did it only considering two resistors, but if you use more than two, you just get the same result. So that's it really. So you just need to know how these formulas are derived or where these formulas are come from. So it's easy to use them and also you know where they come from.